Hey, what's up, guys? Welcome to this episode of Weather Decoded TV. In this episode, I'm going to talk about and give you a walkthrough from the website tropicaltidbits.com. I'm going to show you some of the resources that you can use to track hurricanes, storm systems across the United States. I'm going to show you the different types of models that you can use and some of the very basic features of those models for a complete beginner from scratch. So if you are a complete beginner, this video is for you. This is not for advanced people. That would be repetitive information for more advanced people. But with all that being said, let's get right into this episode. And before we begin, if you like weather forecasting videos, forecasting tutorials, storm chasing, we got it all here on Weather Decoded here. We got play-by-play forecasting breakdowns, weather forecasting tutorials, and storm chasing events. And if you like this, click subscribe, and we'll be releasing more of these on a bi-weekly or so basis. So with that said, let's crack right into this thing. All right. Let's get right into it here, folks. Welcome to the Tropical Tidbits tutorial. Just go right on over to tropicaltidbits.com and follow along with me here. We'll do this like Bob Ross style, except that was a lot crazier than Bob Ross sounds, but we'll just do this real quick here. Click on Forecast Models. And again, if you haven't seen where I go over all of the different model types, the psychology behind the models, when to use them, I got those videos in this playlist. Just watch the previous videos. We're not going to go over them too much here. We're just going to go over the very basics of this website. So we're going to first look, and we're just going to kind of say where everything's at. I'm going to show you where everything's at here. Up on top here, this is where all your models are going to be. This is the current model that's displayed down here. So what we're looking at right now is the GFS model. You can look at all your global models here, ensembles, hurricane, mesoscale, and climate models. We'll go over those, what they are in a second. Over here is going to be your parameters for this specific model. So we're looking at the GFS, and then we're going to look at the different displays the GFS has. So it has total snowfall. It's summer right now, so not going to be much snow. At least I hope not. Hopefully not for a while. You got some snowfall up here. And you can look at all sorts of things, vorticity. Again, all of these parameters and how to use them, that's a whole nother forecasting tutorial. So we're not going to go over them here. I mean, that's going to take several hours. But your very basics, your thermodynamics, what these are, it's kind of measuring heat and temperature and all that type of stuff. So that's what you're going to find in here. Upper dynamics are going to be kind of analyzing the jet stream, stuff way off the ground. Lower dynamics are going to be stuff very near the ground, just off the deck or the surface. So like the surface pressure and stuff like that. And then precipitation and moisture. That's going to measure moisture, humidity, snowfall, rain amounts, future radar, stuff like that. One thing that I haven't said yet is when you see anomaly, trend, and stuff without that, we're going to go over each of those. So the stuff without the anomaly is the actual thing. It's the actual parameter that the model is predicting. The trend is where it's going. So maybe there's a trend in a certain direction. It's cooling in certain areas or it's warming. That's what a trend is. And then the anomaly is how it differs from average. So this is, the heights are much lower than average over here, and the negatives and much higher than average over here. So it's just kind of showing that. So that's what those are over there. Then we got this little section up here. This is to animate it. You can go back and forth. 0, okay, and we'll talk about what this stuff is in a second, but you can just kind of animate it into the future. You can also do it this way by clicking these arrows. You can hit play and it'll go automatically. You can increase the speed, decrease the speed, stuff like that. Over here is your hours, okay? So you can go 6 hours into the future, and that's what it'll look like 6 hours into the future from the model run. 150 hours out, that's what it'll look like. And these will change from model to model. Some models will go further out, some not as far out. Up here is the model run. So the models are typically ran, the global models at least here, are typically ran 4 times a day, or 2 to 4 times a day. And this is in Zulu, which we'll go over in a second here. But if you want to view a previous run, you just click that right there. That was 6 hours ago. 6 hours before that, you can go to the 6Z run. 18 or whatever hours ago is that run. And you can go all the way back several days. And again, the models are run at different times. Each time they run, they suck in all the observations, the satellite data, the radar data, and then they compute a forecast based off that. So, some models are actually ran every hour. So if you go to the Mesoscale models here, the NAM model, we'll try out the, we'll go down to the RAP. There it is, the HRR. That's ran every hour. So, it's depending on what you're forecasting. If you're forecasting long range, global models are going to be better for that. Short range, like thunderstorms, well, you need that stuff pretty quickly and pretty rapidly, so you can get these models every hour. So that's how you kind of change the runs. Now, you can also click previous run down here, next run, and you can look and see how they have changed. Okay, you can see how they have changed. If you see a lot of different variations between the model runs, that probably means it doesn't have the best handle on things. Okay, and if it's generally the same, maybe it's a little more confident. So you can scrub, that's kind of unique. Over here, you can change the regions. So let's say we want to check out the South Central United States, the good old South here. We got storms developing. You can scrub through, you got a better view for that. That actually went off the page, so we'll go back to CONUS. And on this side right here, this is going to be all your legends. So we're looking at future radar right now. This is in DBZ, I believe. And so, that's what you're going to see over here. You got this little cursor here, and that shows the latitude and longitude. And so that's kind of unique as well. And now what we'll go over is what these things on the top here mean and what Zulu is. This little bar on the top, this is going to be where your parameter is, okay, and your model. Your model is right here, and then your parameter is right here. So that's the model right there, and that's the parameter being displayed right there. So that's what that is. This is the measurements, so reflectivities in dBz, the pressures in millibars. Those are very important to make sure you understand what those are, because if it's a different measurement than what you're expecting, it could look a lot different, and that can screw up the forecast as well. This right here, this is a good old website, just whatever, okay. And then we got the initialization time right here. This is when the model was ran. It was initialized at 01Z on September 15th of 2018, and that's what that is. So if I change this over here, if I change it to the previous run, that's going to be 0Z, okay? So that's not the actual time, that's the time the model was ran. And then this right here is the forecast hour. That means we got a 15 right here, so that means it's 15 hours out in advance. Okay, so it's out right here. So if we change that button over here, let's say 14 hours, that'll change up there. So that's now only 14 hours in advance. Valid is going to be when that 14 hours is. So that's going to be 14 hours in advance, which would be 14Z, Saturday, September 15th, 2018. So this date right here, that's the one you want to look for. So what is this beloved Zulu thing we keep talking about right here? Here, 14Z right here. What is that? Is it 1 p.m., 2 p.m.? How does it vary? Well, it's essentially just a time that it's one time across the entire planet. It makes meteorology a lot easier. Otherwise, because you got all these zones, you got Eastern over here, Central, you got Mountain right here, and you got Pacific, etc., and it keeps on going. And that would be kind of a pain to label all of those up here. You'd have 7, 6, 5, 4. And instead, Zulu makes it easier. It's just one time zone across the entire planet. And so that's what Zulu is. And you can actually search for a conversion chart in Google. You just type in Zulu time conversion chart or time converter, and it'll actually, you just type in the time and it'll convert it for you for your area. There's some places for that. So let's do an example here. We'll go back to this. It's 14Z. Okay, so it's 14Z, and it's actually Central Daylight Time, we'll say. And so if we want to find the time for Oklahoma City here, What is 14Z for that? Well, they're in the central time, and we'll say it's daylight time right now, so it's central daylight time. Here's your time zones up here. So ST is going to stand for standard time, and DST is going to stand for daylight time, okay? And so this right here is on the end, the left side is going to be your time zone. So E is east, C is central, M is mountain, P is Pacific. So we want central daylight time. That's going to be this right here, and it's 14Z. And so the numbers in the blue here, or whatever it is, greenish blue here, that's going to be our Zulu time. So it's 14Z right here. We're going to track that over here, and that's going to be 9 a.m. So we've actually figured it out. It's 9 a.m. for someone in Oklahoma City. That's what it's going to look like. We'll do one more example. We'll say we'll fast forward this. We'll go 0Z here. Throw a little trick in. We'll do. Okay, that's, I don't know why, New York City, we'll do that. And that's Eastern time, and we'll say it's Central time now, or Standard time now. So East Standard time is going to be EST right here, and that was 0Z, so you go find 0Z, which is also known as 24Z. So those are the same thing, actually. That's the trick. It's either 0Z or 24Z. They're the same thing. So that's going to be 7 p.m. Okay, that's going to be 7 p.m. for that area. The models typically, the global models are going to typically come out at 12Z, which is this, 18Z, 0Z, and 6Z, which, and let's just say Central Daylight Time again, that's 1 a.m., 7 a.m., 1 p.m., and 7 p.m. So you can write that down. You know, you can go back to this page, you can kind of figure out when the models run here, and you can make a chart. And so whenever you're pumped up, ready to go for the next model run, you got your chart, you know when they come out. And they're typically delayed. That's the other thing you got to watch out for. It says 0Z right here, so you think the model will come out and it'll have all its data ready at 7 p.m. when it actually is delayed a little bit. 0Z is when all of the data gets ingested into the model. It's when it starts computing all of those equations. It takes a couple of hours to process and to put images on the website, and all of that. So that whole process takes a couple hours. So 0Z actually might come out a couple hours later. So instead of 7 p.m., it might be like 9 p.m. All right, so the next section that we're going to talk about is the model types up here. Okay, and again, I talk about these in previous videos in more depth, so we're going to be very brief. And then the little, clicker doozies down here is what we're going to talk about next. So again, right now is the ECMWF. That's what we're looking at right now. If we want to change it, maybe go to the GFS. We just click that right there. These global models are taking data from the entire planet, and they're modeling the atmosphere around the entire globe. The bandwidth, the computer, it takes a lot of data that's ingesting. So they're very lower resolution compared to other models. But they go very far in advance. You can go out 1 to 2 weeks with these models, all the way out to 384 hours, which is a couple weeks from now. And you can see that goes very far in advance. So they're good long-range models. This is what we use to predict systems. They're not as good for thunderstorms and detailed things. They're just good for looking at features like low-pressure systems, high-pressure systems, where the jet stream is, what the general air masses will be. So those are going to be your global models. And you'll have less options typically with these in the parameter section. So we can go to the Canadian here. We'll click on lower dynamics. We'll look at temperature, advection, and there you go. Your bar on the right here to see what you're looking at, and stuff like that. And you'll also notice with the models you have different layers. So these are your wind barbs. We have separate tutorials on that probably, or will soon. You got your temperature lines here. Your fill is going to be your temperature advection. So you have different things on top of each other, and it's important to know what each feature is. Look at ensemble models. These models are variations of the same model. So say the GFS or the ECMWF. This is called the EPS. It's the ensemble of the ECMWF. So what they do is they take different initial conditions and different calculations, and they run the same model, but they just change things up just a little bit to account for potential error, and then it smoothens it out. It finds the average solution, and that's what this is. So this can kind of be good for diagnosing things that you're not sure, the confidence on what's confident and what's not with this model. And that's good, especially for long-range forecasting. Ensembles are. And the next section is the hurricane models. Pretty self-explanatory. That's zooming into any current hurricane or tropical system that's out in the sea, and you'll get some special dynamics, special parameters to examine the hurricanes, and they're very zoomed in. Okay, so there's specific models for the hurricanes. Mesoscale models, these are going to be your zoomed in models, like the HRR. That's going to be specifically for the continental United States. It's a model that takes only that area of data in and only calculations. And because of that, it can actually account for higher resolution because there's not as much data. These are less accurate farther out in advance because if you have features like maybe something over here that's off the model grid, once it enters the model grid, it can start causing chaos in the edges here because it didn't account for it, and it starts to kind of populate the model over time, cause inaccuracies and stuff like that. Or it takes model data from some other larger scale model, but this is a different model. So either way, it's going to cause some inaccuracies past about 18 hours, 12 to 18 hours in advance. So these are good for daily looks at highs, lows, thunderstorms, temperatures, and stuff like that in fine detail. And then your climate models can go out weekly and even monthly. Okay, so this can go out all the way to June 2019. Right now it's October 2018, so that's a whole year in advance. And again, these are extremely low resolution, broad generalizations. So with climate models, all you really want to examine is where are the troughs and ridges and the types of patterns. You don't want to get more detailed than that because there's going to be a lot of different variations. Just big, strong signals is what you want to look for the climate models. And then you can change the regions down here. So again, eastern U.S., maybe you want to go to Alaska. You can go to Alaska here. Hey, maybe you want to go across the world to Australia. You can look at Australia right there. So you can go across the United States, and it's pretty cool there. And not all models are doing that. Remember, it's only the global models that can do that in the climate models. If you want to do a GIF, you can just click this right here. You can make a GIF. You can do your start hour, which is when it starts. Well, we don't want to be playing it. But anyway, you can do your start hour, your ending hour. If you maybe go 8 hours into the future, the speed's 5 frames per second. You can skip different hours, and then you can create a GIF, and you can download it to your computer. A trend GIF is going to be the model trend. So the previous few model runs, you can do the past 7 model runs for a specific hour, and then create a GIF on that as well to see how accurate and how much confidence the model has. All right, guys, and the next clicker doozy that we're going to be dealing with is these little 2 things up here. This first one is a little settings button, and you can turn things on and off. Point and click soundings, you can turn them on and off. We'll go over that in a second. Space saving mode, what that does is it'll actually take out some of the top and bottom and side menus and stuff, and that actually takes out some of the coding, I think, and it just saves up it makes things go faster essentially. This little keyboard right here, these are commands, so you can use your keyboard to make things go faster, like move left and right. Just click the left and right arrows. That makes the model experience a lot easier, I think. And so there's some buttons here. Now, we're going to go over some special features here. We're going to go over soundings, average soundings, vertical cross sections, and the ruler here. So let's look at the ruler. That's pretty simple here. Shift plus drag. So you just click Shift, and then you drag the mouse, and you can see the readouts. So say you want to go from Fort Collins to Wichita or something. That's 372 nanometers, 689 kilometers, just like that. Then you can do other things like view a point sounding. You're just going to click right on the map wherever you want. These soundings are only available for certain models. This isn't for every model, but let's say Nashville or something. All right, and when we click a sounding, this is essentially what a sounding is. It's measuring the atmosphere in a vertical for a given point. So this area up in Nebraska, maybe near Ogallala, it's, the bottom of this image is going to be the surface, and the top is going to be way up high. Okay, and the jet stream is usually somewhere in there. And so we can just kind of get a 3D view. We get temperatures, dew points, and you can calculate a bunch of different stuff from just that data there. And there's, we might have some tutorials on that in the future. That's a whole nother course in of itself. But essentially, that's what you get with your sounding. So you can change your models. So the GFS, you can check the sounding of the GFS and other models down there. And again, that's what the model is predicting the atmosphere in the vertical will look like. It's not the actual sounding. It's what they predict it'll look like. You can change the model runs right here. You can fast forward your hours right here. Change the light and lawn right there, so you can change the location just by doing that. You can type in a sounding ID in there and stuff like that. So that's how you do that. You can save the images if you want up there as well. Then to find an average sounding, an area average sounding, we click and then we drag. So we're going to drag. What this is going to do is it's going to find the average conditions in the vertical for this entire box. So it'll take that box and it'll average everything out. And sometimes it won't work because things vary too much. You kind of have to click in an area with a similar air mass, and it'll make an average, how much it changes from here to here. It's going to average it out essentially. So this is good for examining different air masses. When you kind of go over like a cold front or something, it's going to vary too much. So this is good for mostly just examining different air masses, like a warm air mass, a cold air mass, a dry air mass, and a moist air mass. And you also can change your light lawn box down here as well. So that's kind of interesting, and this is really the only website that I've seen that's carried that. So that's a pretty interesting tool. Again, all of these different websites have different pros and cons, and that's definitely a pro. And then what we're going to look at is a vertical cross section. We do control if we're on a PC, or command, click and drag if we're on a Mac. So we'll do that real quick, and then we'll drag. And a cross section is measuring the atmosphere on a vertical from one distance to another distance. So let's go up to like Wyoming here, and then we'll go down to Dallas, and we can change the types of things here. Okay, we'll go to potential vorticity, hit submit. Then what this is going to do is you're going to get a vertical cross section here. So this over here is going to be your area up near Wyoming, and this is going to be Dallas down here. And so this is looking at atmosphere in the vertical. The surface is this little brown area right here. Anything below that is below the surface. And so we want to look at things above it. So here up in Wyoming, it's probably somewhere between 9 and 800 millibars. And here in near Dallas, it's going to be closer to like 1,000 millibars. So where the surface is, that's important to know when you're calculating this stuff. And then so this is the surface and then everything above the surface. And we're examining wind, potential temperature, and potential vorticity. So that's what it looks like just above the area in Wyoming near Casper. That's what your measurement's going to look like. And then this is what it's going to look like down in Texas above the surface, and everything in between along that line. So these lines are good for picking out fronts and stuff like that, areas of pressure, changes in the air mass from point A to point B. So those tools are useful for those types of things. And then, I think that's about it for those in this section. There's other hotkeys that you can use for other things that make things a little bit quicker. So that's pretty much it for the old Tropical Tidbits tutorial here. This actually is ran by Patreon. This is a guy that develops models, and you can actually support him on Patreon. Check that page out. And I think as he gets more donations, I think these models are going to continue to get more features. It helps them run. So I definitely recommend checking that out if you really use this website a lot and find it useful. And so with all that said, that wraps up this tutorial for Tropical Tidbits. Again, if you want to see those other models that discuss more about the weather models and just kind of the basics behind them, I got some other videos on this channel, or we'll be uploading them very soon. And they should be in this playlist, the Weather Models Guide playlist. So with all that said, hope you enjoyed today's video. Again, if you like videos like this, subscribe. If you know some weather friends, share it with a friend. And hope you found this video useful, and we'll see you soon.